Okay, right. Good morning, students. Today we'll see a new topic, right? So we'll start electrostatics, right? Before that, a small introduction, then we'll go into the topic. Okay. Okay. So first, in 12th, in the first part, whatever the topic it might be, in the first part of your NCRT, whatever the part it might be, it comes under electromagnetism. It comes under electromagnetism. Electromagnetism. In the sense, it's a study of charge. What do you mean by electromagnetism? It is nothing but the study of charge. It's a study of charge. So charge is at rest, charge is moving with constant velocity, or charge is moving with some acceleration, accelerated motion. All the topics comes under this topic called electromagnetism, study of charge. Whether it is at rest, or it is moving with constant speed, or it is accelerating, what properties that charged particle is having, all the things comes under this main topic called electromagnetism. And according to your syllabus, this will be divided into three parts. So one is electrostatics, and the first part is electrostatics. Here what we study? Electron or the charged particle. Not only electron, a charged particle I can say, right? So a charged particle should be at rest, right? So what if a charged particle is at rest, whether it is a negative charged particle or it is a positive charged particle? Charged particle is important. Negative or positive. A charged particle, if it is at rest, whatever the properties will be exhibited by that charged particle, everything we will study in the electrostatics. Alright? So should be at rest. The next part, right? So charged particle is at rest here. Now the charged particle will move with charged particle. Charged particle will move with a constant speed. A constant speed. So charged particle moves with a constant speed, then what will happen? What is the properties exhibited by that charged particle? All the things we'll study in this part. I think according to your NCRT, this comes under current electricity topic and as well as magnetism also. If a charged particle will move, what will happen? Definitely electric fields will be there and as well as magnetic fields also will be there. So if a charged particle is moving in this direction, then definitely electric field will be in this direction, for example, and magnetic field will be in this direction. If these two are perpendicular, then charged particle will move perpendicular to electric and the magnetic fields. Yes or no? So is that clear? E bar cross B bar. So in which direction the charged particle will move, given by E bar cross B bar, right? So we'll see later that, don't worry about that. So charged particle moves with a constant speed. So if it is moving, then we have to study a topic called the current electricity and as well as magnetism, right? And next, third part, charged particle can accelerate. Yes or no? It can accelerate. So whenever a particle accelerates, it will lose some energy. As about energies and all, we have to study here when the charged particle can accelerate. Not only charged particle, whatever the particle it might be, if it accelerates, what will happen? Energy will be lost. So now that topic, according to here, we study in electromagnetic waves. So we divide into different spectrum, different wavelengths, different rays, right? So all those electromagnetic spectrum we will study here based on what? Based on the energy at that particular level. That energy, why it is different? It is accelerating. Who is accelerating? Charged particle is accelerating, right? So wavelengths will be different, visible region, X-rays, gamma rays, cosmic rays, whatever the thing. Every electromagnetic spectrum, each and every part we have to study here, right? So the first part basically comes under all the chapters. I think we covered complete magnetism. In the sense it might be EMI, it might be alternating current, everything. Everything comes under in this electromagnetism. Right? So first in this topic, in this class, we will study electrostatics. In that especially, we will study about electric charge. About charge, we have to study. Alright? Now. Right? So please revise the basics. Now each and every point in the basics we won't study. Why? Because already the board level classes we have seen all the things. Now we'll see the points which are important in the problems. Okay. Right. So about electric charge. About electric charge. So right. So now, what do you mean by charge? So whatever the particle in other words we can take, whatever the particle, either beam or marker, or whatever the things it might be, it is made up of what? Matter. Yes, or no? So all the particles are made up of matter, atoms for some particles, So inside, what is that particles in the sense? That will be a charged particle. Yes, or no? So whatever the object it might be, if you take, that is made up of what? Matter. So that is indirectly I can tell charge is present. Might be a neutral body, might be a charged body. So whatever the things it might be, if you go inside, what will happen? Definitely charge will be there. According to me, I can tell charge is an inbuilt property of the matter, whatever the object it might be. It is an inbuilt property, inherent property. Yes or no? So whatever the particle, whatever the object it might be, so it is made up of what? Charges. Might be a neutral body, positive or negative charges might be same or might be different. So that is secondary, that depends on the object. But everything is made up of what? Charges. Right? So apart from that, nothing we can study here. So first we have to study about the properties of the charges, important properties. What is useful for the problems, those properties we will see now. Okay. So now properties first one. So what is SI unit of charge? We'll go a little fast, we know all things, right? So it is nothing but Coulomb. So two types of charges will be there, yes or no? So two types of charges, that is nothing but positive charged body we call, or positive charges we call, or negative charges we call, right? Charges will be there. One is positive charges and the other one is negative charges, right? Positive charged body we call, or negative charged body we call. So neutral body also we call, in the sense what? That is also made up of these positive and negative charges only, but the number of positive charged particles and the number of negative charged particles will be same. But the point, so in nature two types of charges will be there. But so neutral body or the neutral charge won't be there, neutral body will be there, in the sense the number of positive and the negative charges will be same. Right? And next, coming to the important points, which is conservation of charge. Conservation of charge. Right? So before going to this conservation of charge, can I give a question? So try to do this. For example, 11th physics relation is there, that's why. Here conservation of charge we call, in 11th what we studied is conservation of energy. Conservation of what? Energy we studied. So for example, consider two particles, one is of 2 kg mass and the other one is of 4 kg mass, separated by some distance, assume 2 meters, whatever. Right? So 2 kg mass particle here and 4 kg particle here, separated by some distance which is assumed 2 meters. Now what I did is, this 4 kg mass due to some internal forces, due to some, point is important, due to some internal forces, this 4 kg particle is moving away from the 2 kg particle with a speed of 10 meter per second. With a speed of 10 meter per second, find the speed of 2 kg particle. Is that clear about the question? Concentrate. So I can say two particles, one is of 2 kg and one is of 4 kg, separated by some distance. Now 4 kg particle is trying to move with some speed due to some internal forces. Underline that point. Due to some internal forces, this 4 kg particle is moving with a speed of 10 meter per second. Then what will be the speed of this 2 kg? Whether it will move or it will be at rest, or what will happen? Definitely it will move due to some internal forces, I said. So if it is due to some internal forces, what will happen? What will happen? There is no external force acting on that. Please try to revise vectors and as well as some basic concepts of conservative forces, work energy, power concepts. and vectors. If you are perfect in those two chapters, then this part will be easy, or else no. Right? So first basics, what is that? Vectors and as well as work, power, energy, conservative forces. Why conservative forces? I said electrostatic force is a conservative force. Then what are the properties comes under conservative force? If you are thorough, then these problems we can do easily. Right? So external force acting on the body equals to 0 according to my question. This 4 kg particle is moving with some speed. Okay, it is moving with some speed due to what I said, due to internal force I said. So external force equals to 0 and internal force is always opposite in the direction, so they might be cancelled. So net force acting on the body, which is equals to 0. Understood that point? Internal forces attractive in nature according to the masses. Masses always attractive in nature. Yes or no? Right? So now if you stand here, attractive. If you stand here, attractive, then what will happen? Both are opposite in the direction. So internal forces opposite in the nature and the same magnitude, they will be cancelled each other. So that's why external forces, I am not giving any external force on this system. Internal forces opposite in the direction, they cancel. So I can tell net force acting on the system equals to 0. Or you can tell external force acting on the system is also 0. Both are correct. Now what I can write? Force which is equals to a rate of change of momentum. So if net force equals to 0, then I can tell when force will be equals to 0 according to this equation. Momentum should be 0 or momentum should be constant. Momentum should be constant. So we call this concept as conservation of momentum. Conservation of what? Momentum. In 11th we studied about this conservation of momentum as well as conservation of energy also. Likewise here we have to study about the conservation of charge. Now what is the answer? So if internal forces cancel each other, if there is no external force, where center of mass will be? Center of mass will be at rest. If for example assume center of mass for these two particles is here. So it is moving with 10 meter per second and center of mass will move this side or this side. Center of mass won't move, that will be at rest only. If center of mass is at rest, then with what speed it should move such that center of mass will be at rest. Right? So what I can write now? M1 V1 which is equals to M2 V2. Yes or no? So momentum will be constant from this. Force is 0, so momentum will be constant. If momentum is constant, what I can do? Momentum of this one and momentum of this one should be same, but opposite in the direction. Okay, minus I didn't write. I am trying to calculate the magnitude. So if you want with the direction, you can go for minus this one and this one definitely should be opposite in the direction. Right? So M1 V1, so I can write 40, which is equals to what is M2? 2 into V2. So with what speed this should go such that center of mass should be at rest? So it should move with 20 meter per second. Right? So it should move with what speed? 20 meter per second. Then center of mass will be at rest. So we can write conservation of momentum in those cases. When we have to write conservation of momentum, if there is no external force acting on the system, then we have to write. Everything is related. Sir, why you went to there? So you have to discuss about conservation of energy. No, everything is related. Here also we can write conservation of momentum with respect to charges. We have to write conservation of energy. You have to know, and then conservation of charge. Three concepts comes in this topic called charge. Alright. So this is the way how we can write conservation of momentum. Now come back here. Charges also will go on. Instead of masses, later on I will take the charges there. One charge is moving in that direction with 10 meter per second, less only, but okay. One charge is moving in that direction with 10 meter per second. With what speed this charge will move such that center of mass of the two charges will be at rest. Same concept can I apply or not? Definitely we have to apply. Right? Now, conservation of charge. What do you mean by conservation exactly? Just now we discussed more stories about conservation, right? So what do you mean by conservation of charge? Whenever if you say conservation, that is nothing but constant, right? So charge neither be created nor be destroyed, but it can transfer from one body to another body. Yes or no? So it can be transferred from one body to another body. What is conservation? It is constant. What is constant? Charge will be constant. How it will be constant? Constant in the sense I won't give anything to anyone. No, not like that. In a system. In a system. Take a question. Start doing this. consider a system. In that system, I considered some 2-3 bodies. Okay, 3 bodies, right? So initially on these 3 bodies, assume body A, B, and C. So initially on the body A, I placed some plus 5 coulombs charge, right? So and on body B, I placed some minus 3 coulombs charge. And on body C, I placed some plus 2 coulombs charge. Initial charge. What is the initial charge on the 3 bodies? On 1 plus 5, on 2 minus 3, on 3 plus 2 coulombs. It is the system. I consider these 3 bodies as a system. Right? So now I did some process on this. Might be conduction, might be induction, might be friction. Which try to revise today. Okay? So might be conduction, might be induction, and might be a friction by rubbing all these 3. I did some process. Okay? So in the system, with these 3 bodies only, I did all those things. Not any other material I didn't take from the surroundings. Right? In the 3 bodies, I did some process, and finally the charge what I got is, consider. So I got on this plus 3 coulombs, and I got on this minus 3 coulombs. So find the charge on the body C. Final charge. Start. Find the final charge on the body C. So initially plus 5 minus 3 plus 2, and finally plus 3 minus 3. Then what will be the charge on the body C? So in the sense, what you have to do? Initial charge and the final charge both should be same. That is nothing but conservation. Initial and the final charges both should be same. What is the initial charge? It will be 5 minus 3 and plus 2. So how much is this? 5 minus 3, 2. That's how. So 2 plus 2, it should be 4 coulombs. Initially it is 4. Finally also on the system, how much it should be? It should be 4 itself. Alright? And now, according to me, on the first body, I gave it as plus 3 and minus 3. Then how much we have to write on the third body such that you have to get 4 coulombs. So these 2 will be cancelled. Now on body C, how much charge should be there? 4 coulombs. Right? So plus or minus? Plus. So this will be the charge which will be there on what? On the body C. So they will be exchanged. But the sum of all the charges before and after doing any process definitely should be constant. Alright? And next. Quantization. This is the story that what you have to understand. Remaining things I think you know. I write the formulas and we can go for the questions. Alright? So next. Quantization. Quantization of charge. You know the things. What do you mean by quantization of the charge? Charge always the integral multiples of the basic unit of charge. So total charge on a body. Total charge on a body is nothing but the integral multiples of the basic unit of charge plus or minus. Right? So charge never be in the fraction. Never be in the fraction. E by 2, 2e by 3, 4e by 4, 5. So it won't be possible. Charge never be in fraction. So you have to write n value like 1, 2, 3 and so on. Positive. It is an integer. It is an integer, starts from 1. So E value can be negative for negative charged particles, can be positive for positive charged particles, but n value always should be an integer. So what is E? Basic unit of charge, which is 1.6 into 10 to the power minus 19 in coulombs. How we got this? I think in Untitled Chapter, I said a story and I calculated this 1.6 into 10 to the power minus 19 by using an experiment. Right? Both are related. Everywhere you go, it will be related. So how you got this value? In the sense, again, we have to go for modern physics, we have to see some experiments. There, I think we discussed about this 1.6 into 10 to the power minus 19 coulombs, right? So now Q, which is equals to plus or minus NE, where N is an integer and E is the basic unit of charge. So if it is a positive charged particle plus, if it is a negative charged particle, it will be minus. Right? And the next one, after quantization, so it will be additive nature, right? So it will be the additive nature. What do you mean by additive nature? So the net charge, which is equals to the sum of all the charges present in the system, right? So I think we know that. What is that last one? Additive nature. What is additive nature? the net charge acting on a system which is equals to the sum of all the charges present in that system. I'm talking about that particular system. I'm not talking about the whole world. In that system, what I considered, for example, the previous case. I think this is the best example for this additive nature. What I did here, I added all the charges of all the bodies or not, initial and final. Why I added? So it is a system. What will be the net charge I want? So I added. That is nothing but the additive nature. Already example we discussed. Right? So if you want what is the net charge in a system, definitely we have to add all the individual charges present in that particular system. Alright? Now, this is the basic properties that what we have to revise before going into the problems. Right? Next, keep reading Coulomb's law. Coulomb's law. The same as in the sense with some changes, almost similar to the gravitational force, universal gravitational law, what we studied in electrostatics. Right? Almost similar. If a medium is not changed, almost similar. If medium changes, that force doesn't depend on the medium. If two masses, if I place any medium, force will be constant. But if two charges placed in any medium, then force varies. Apart from that, remaining all the things we can compare. Right? If medium changes, then we can't compare. Why? Because their force will be same if medium changes. But here, if medium changes, then what will happen? Force will be changed. So medium concepts we will see later. Then first we will see the basics with the problems. Then tomorrow we will see about the medium. Okay. So come back to the concept. So tell me what is Coulomb's law? I think statement are not required. So already we know. So consider two charges Q1 and Q2 separated by some distance which is R. So what I can write? Force is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. If you combine those two statements, I can write F equals to K times of Q1 Q2 divided by R square. So where K is 1 upon 4 pi epsilon naught. Permittivity of free space. Permittivity of free space. So this is the constant. So where K value will be equals to 9 into 10 to the power 9 and epsilon naught value will be 8.857, some books they'll write 4, some books they'll write okay, into 10 to the power minus 12. 8.85 into 10 to the power minus 12 and this is 9 into 10 to the power 9, substitute here. So this value if you substitute here we'll get this value 9 into 10 to the power 9. What do you mean by permittivity exactly? So I won't add that much. Why? Because that is not your level. But okay, you have to know the meaning of permittivity first. So what do you mean by permittivity exactly? For example, consider two charges. So definitely repulsive force will be there. Why? Because I didn't particularly place the sign of the charge. So definitely both should be positive. So if it is negative, definitely I have to write that as negative. If I didn't write, both should be definitely positive charges. Now, what I mean by permittivity exactly is, so from this charge, assume, from this charge, according to me in one sentence also I can tell about permittivity, that is nothing but number of field lines that what it can send from one place to another place. That ability of sending the electric field lines from one place to another place, we call it as permittivity. Simply, but you can't understand, I think that statement. If you understood, okay, very good. So now Q1 and Q2 separated by some distance. Now, for example, what will happen? By this charge, on this charge, definitely force will be there. Yes or no? Definitely force will be there. Now, based on the magnitude, that force will be there. Yes or no? Based on this magnitude, that force definitely will be there on this. Or by this, on this. First consider anyone, don't be confused. I am considering Q1, by Q1, on Q2, I am discussing. Right? Now, I gave magnitude to Q1 in such a way that it should apply the force or it should release some energy like 100 joules. Based on that energy only, no force will be there on the other charge. Yes or no? So I gave some magnitude on Q1 such that I hope that it should give the force based on 100 joules energy on Q1. Okay, but it released 100 joules. Step by step, I am calculating everything by an experiment, by some device. So it released 100 joules of energy based on that magnitude. Okay, it released. So that 100 joules of energy should travel from one place to another place or not? So if it is air or a vacuum or free space, then what happened? Happily that 100 joules of energy went from one place to another place. So based on that 100 joules, happily force also there on Q2. Now these two charges I placed on other medium. So what we hope? 100 joules of energy should come out. Yes, it came out. It came out. But some loss will be there on that energy due to the molecules of the water. Yes or no? There also charge will be there. So 100 joules of energy came out. Then what happened? While traveling from one place to another place along a straight line, some force or some energy will be what we call will be lost or not? Yes or no? Definitely will be lost due to the other molecules. So how much it went? Assume for example 40 joules went. So another 60 joules, what happened to that energy? That is lost. That is lost in the sense based on that the field lines also will be lost. So force also will be lost. As of that will be decided by a property called permittivity. Clear about that point? Permittivity. I am talking about permittivity. This is epsilon naught. I am talking about the permittivity which is epsilon, absolute permittivity I am talking about. Right? Clear about that point? How much energy it releases? The same energy based on that the force which is acted on the other charged particle, then no loss is there. Right? So now if I change the medium, then what will happen? Definitely loss will be there in energy based on that force. Definitely loss will be there. So for example, 10 newtons of the force it should act on this, but now it will act less or more. Definitely it will be less. So it will be decided by whom? Permittivity. Right? So if medium changes, this value changes. Clear? Now in any medium, then we have to use this formula. Right? So try to understand F equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. If I write this formula, you can apply only in a free space, vacuum we call, air we call, so free space we call, right? So we have to use this formula there. Now in any medium, if I want to apply the force formula between the two charges, then I can write it as 1 by 4 pi epsilon Q1 Q2 divided by R square. So this epsilon depends on the medium. Depends on what? Depends on the medium. Absolute permittivity we call. So epsilon I can write it as epsilon naught and epsilon R. So this epsilon R is nothing but relative permittivity. This relative permittivity, what do you mean by relative? Many times I think we discussed. What do you mean by a relative? Comparing. Comparing with what? With air or free space. We are comparing with epsilon naught, how much the medium change, who will give that value? Epsilon R will give that value, and that epsilon R multiplied with K, that will be the absolute permittivity. Try to understand the point? In air, that epsilon, sir, here also you can write epsilon R, why you didn't write? In the sense that epsilon R value will be equals to 1 in free space, in air or vacuum, right? Free space we call. So epsilon R value will be what? Will be 1 there. If medium changes, this epsilon R value will increase. If increases, epsilon increases. If epsilon increases, force decreases. Why force decreases? Based on the story what we discussed. In between some loss will be there. Due to that loss, force also decreases. Right? Clear about the point? Right. Next point what we have to discuss here is about central force. Right? So what do you mean by central force? Coulomb's force is a central force. You can see in any standard books. What is that? Coulomb's force is a central force. What do you mean by central force? We know that. So consider two charges separated by some distance. So these two charges are here. Now the force exerting on this charge by Q2. What is the direction? Most of the students again will make mistakes in the directions. Right? Try to understand clearly. Okay. So if you want to calculate the force on Q1, you have to stand on Q1 and you have to see Q2 is there near you. Alright. So now you are standing here, that is also positive charge, positive, repulsive force. So you have to move in the other direction. Repulsive force, yes or no? So definitely you have to move, so the repulsive force will be there in this direction. So now if I want to calculate the force on Q2, then you have to stand here and then the repulsive force direction will be here. Then where you people will make mistake, generally, not everyone, generally. So if I consider Q1 and Q2, so said opposite forces will be there. Yes or no? Forces definitely opposite in the nature. Okay. So if I said to calculate the force on Q1, they write like this. Right? And Q2. Okay, we know this is repulsive force will be there. But if I ask only on one, definitely everyone will tell in this direction. Sir, repulsive only no. So it is going in this direction, that is repulsive or attractive. You have to stand here and you have to see. So repulsive force will be in this direction on this one. It won't be in that direction. If I ask on Q2, it should be in this direction. It won't be in this direction. Both should be opposite in the direction. So now coming back to the topic, what do you mean by central force? The force which exerts on the line joining between the two charges. The force exerts between, if you want to write a point, the force exerts between the line joining between the two charges. The force exerts between the line joining on the two charges or between the two charges. Or always the force, Coulomb's force, will act either attractive or repulsive, whatever the nature of the charge it might be. Definitely you have to join the charges first and you have to extend or you have to go into that line. Alright, so that is nothing but central force. Clear about that? So exerts between the line joining of the two charges. So for example, one charge is here, another charge is here. So if I ask to write the force on Q1, is it possible? So Q2 is here. So by Q1 on Q2, if I ask force, it will be correct. It will be correct. So which one will be correct? Definitely this will be correct. These two will be wrong. Why? You have to join a line. Based on that line, we have to write the forces. That is the central force. Right? Now next point. Coulomb's law satisfies Newton's third law. It's an opposite in nature. But what about the magnitude? So here Q1. I'm there on Q1 and I calculated the force magnitude. And then I stood on Q2 and I calculated the force again by using any one of these formulas. Alright? So now assume it is force on 1 by 2. Yes or no? I'm standing here now. Right? So force on 1 by 2. Now if I'm here, force on 2 by 1. Force on 2 by 1. Both are definitely opposite in the direction. So I can write F12 which is equals to minus of F21. With vectors opposite in the direction, right? Then what about magnitudes? If I write with magnitudes, modulus of F12 bar, which is equals to modulus of F21 bar. So according to the magnitude, both are same, but according to the direction, minus should be there. Both are opposite in the direction. So it satisfies the Newton's third law, and it should follow central force. And one more thing, this formula we can apply only for point charges. What is that? Only for point charges. Coulomb's force applicable or valid only for point charges. So if it is not a point charge, then we have to go for some other process. We have to apply this formula only. But directly for that object, we can't apply this formula. Indirectly, we have to apply. How to apply it all? We'll see in the later classes. Now, what is the last point? Coulomb's force, right? So is valid only for point charges. Only for point charges. One more property, try to think. For example, in a system, take a question and try to analyze that. Okay. So in a system, for example, Q1 and Q2 and Q3, Q4. So assume 4 charges are there. How many? 4 charges are there. Now I asked to calculate, find the net force on Q1. We'll analyze everything. So find the net force on Q1 if I ask. Distances you can take your wish, but don't ask me. Okay? So take R1, R2, R3, whatever. So what I ask, net force on Q1 if I ask. So assume Q1 to Q3, the separation is R1. And Q1 to Q2, the separation is R2, and Q1 to Q4, the separation is R3. So find the net force on Q1. I think the same point we discussed recently in the wave optics also, right? So what is that? Superposition principle. Yes or no? So in waves we can apply, and here also we can apply, right? So what is that superposition principle? The net force acting on any particle which is equals to the vector sum of all the individual forces. Yes or no? The vector sum of all the individual forces. So if I want to calculate the net force on one, it should be equals to force on 1 by 2. Yes or no? Yes. And force on 1 by 3 and force on 1 by 4. So this concept, vector addition, that is very important. Vector addition. So that's a revised vectors. Then this topic will be easy for you, right? So net force, which is equals to force on by the other charges on the charge where you are calculating the net force. Clear about that point? Alright? So Fm bar, which is equals to the vector sum of all the individual forces acting on the system. Now my question is, so on the way it came, so I said, okay. So now my question is, the force between Q1 and Q2, force between Q1 and Q2, force between Q1 and Q2 is dependent on the forces acting on the other system, dependent on the system will be better, right? So the remaining forces in the system, yes or no? Force between Q1 and Q2, just like I said, the force between Q1 and Q2 is dependent on the remaining forces, independent of any two charges in the system is independent of charges or the number of forces present in the system. Alright? So if I answer Q1 and Q2, so the force between these two doesn't related with Q1, Q3, Q1, Q4 and so on. How many number of charges it might be? It doesn't depend. Alright? So very important. So answer from my question is absolutely wrong. So it is independent on the remaining charges present in the system. Right? So this is about some important properties of Coulomb's law. Alright? So we'll do some questions now. Right? Start doing. We'll go from the basic. Right? So first question, very basic question. Start doing. So two charge system, I think not required. Only two charges are available by some distance. Not required. So three charge system will go. Right? So consider three charges, Q, and Q. Right? So based on the three corners of an equilateral triangle, side A, it's an equilateral triangle. It's an equilateral triangle of side A. Find the net force. Find the net force on C, on the charged particle placed at C. So shortcut I have written. What is it? On the charged particle placed at C. Start with. Is a clear question? Equilateral triangle of side A. Find the net force on C. Directions also we did. So if two positive charged particles are there, what will be there? Repulsive force, and one positive, one negative. Attractive forces will be there, right? So central force we know, and all the points we discussed based on that. Right? After a minute, I do. Okay? I know I have to calculate here, so I wrote everything. Don't worry about that. So it will be charge here. Right. Now, first what you have to do? You have to draw the directions. Little fast. I think we can go. So B and C. Positive, repulsive force. So force, can I take it as B, force on C by B. And next A and C, this one, right? So repulsive force again positive. So it is force on C by A. Only two forces, right? Three charges, and I am standing here. So repulsive force, and by this on this again repulsive force. Yes, right? And then, so what is the angle between the vector addition or what? Scalar addition or vector addition? Definitely vector addition. So then I have to write the magnitudes first. So write the magnitudes. So what I can write? So CB, you have these two, the sun is A, I can write it as A Q star divided by A square, and FC by S2, that will also K Q square divided by S. Once more, I to write in the note whenever you are write the sun. Okay, so write magnitude of write the sun. Okay, so write magnitude of substitute only in the magnitude charges. That minus sign will tell you whether it is attractive or repulsive. Only we have drawn directions, then you will be confused. Directions tells you, so substitute only with the magnitude. Next, magnitudes are common. Now vector addition, angle between them also we know. So this angle we know as 60 degrees, and definitely this angle also I can take it as 60 degrees. Then I can write FCB and FCA both are same. So vector addition. So tell me what I can write to calculate the magnitude. I equals to square root of A square plus B square plus 2AB cos theta. And if you want cos theta, so vectors, try to remember how to calculate the resultant magnitude and as well as the resultant angle. Now, what is the angle between the vectors? 60 degrees. So substitute it will be same. So it will be square root of FCB, FCA. Both are same. Can I write FCB first problem? So I am writing everything. FCB and FCA both are same, and I am considering it as F. F and B is also F, so it will be F square plus 2F square cos 60 1 by 2. So 2 will be cancelled. F square plus F square plus F square. It will be root 3 times of F, which is root 3 of what is F? Anyone you can take. That will be KQ square divided by A square. That's it. Right? So now root 3 KQ square divided by A square. Now if I ask to calculate the angle, so what I can write? Alpha, which is equals to B sin theta. So which one is B, which one is A? So what you have to do now? So first, so the tail of the two vectors at one place. So definitely we can apply parallelogram. The tail of the two vectors at one place. So definitely we can apply a parallelogram of vectors. Parallel to this, can I draw an imaginary line here? And parallel to this, can I draw an imaginary line here? So both can I join with a line from the same point? So this will be the resultant. Yes or no? This will be the F net with magnitude of how much? Root 3 times of F, and angle, how much angle? So if I consider this as alpha, whenever the resultant angle, if you consider with any vector, this represents A and this represents B in the formula. Is that clear? Alpha, if I consider this side, then this will be A, this will be B. So alpha is here, then that will be A and this will be B. Don't be confused. Okay. So tan alpha now B is what? Both magnitudes are same. F sin theta. What is theta? Total angle between them 60 degrees. So sin 60 is root 3 by 2 divided by again F plus F cos 60 again. What is cos 60? It will be 1 by 2. Right? So sin 60 root 3 by 2 and cos 60 1 by 2. So try to calculate that. That will be your answer. What is it? Root 3f by 2 into. So 2 can I take LCM? 2f plus f, 3f. So it will be 3f by 2. So it will be 2 by 3 times of f. So ff and 2 will be cancelled. So tan alpha will be how much? 1 by root 3. And with that we can calculate alpha. Is that clear? Yes or no? Calculations 2f plus f, 3f by 2, so reverse. So it will be 2 by 3f, so it will be 1 by root 3, so it will be 30 degrees, right? So equally will be divided. Why equally divided? Magnitudes will be same. Alright? Sin 30, 1 by 2, and cos 30, root 3 by 2, so it will be 2 by root 3, 2 cancel, so 1 by root 3. So alpha, which is equals to 30 degrees. If magnitudes are same, this line will be an angular bisector. If magnitudes are same, then the resultant line will be an angular bisector. So if 3 charges are there, this is the way. Now 4 charges, I'll give the assignment for you. Try to do. We'll go with some difficult question, right? So now next task for you. Consider 4 charges now placed on the 4 sides of an square. 4 sides of a square. So one positive, one negative, again one positive, and again one negative. So A, B, C, and D. So it is a square of side A. Is a square of side A. Find the net force at point C. Find the net force at point C. In the sense, a negative charge placed at point C. Find the net charge here. Right? Understood the question? So try to do that. Next. So on this, if I increase the level, then question will be like this. So whatever we are doing now, this concept comes under what? Superposition principle. Why? The vector addition we are doing. Alright? So comes under what concept? Superposition principle. Take this question now. Start doing. So after this, we'll go for the next model. So only electric charge is there for this week. So we have to discuss all the models for the next coming 3 classes. Right? So story, nothing. F equals to 1 by 4 times 1, 2 into 2 by r square. So how we have to apply in the different cases that formula, that we have to see. Right? So medium changes and all we'll see in the next class. Now in the air medium only we are doing. Okay? So start. Consider a circular shape or like a watch. Alright. So now this is the center, and take some charges here, 12 coulombs. So 12 will be there. So 12. So 1 and 2 coulombs, and 3, 4, 5, 6, 7, 8, 9, 10, and again 11. So at the center I placed 1 coulomb charge. At the center I placed 1 coulomb charge, right? So 1 coulomb charge, and the radius of this circular path is 1 meter, and the radius of that circular path is 1 meter. Radius is how much? 1 meter. So now the question is, find the net force on 1 coulomb charge placed at the center. What is the question? Find the net force placed at the center, right? So find the net force placed on the charge, 1 coulomb. Okay, find the net force on the charge, right? So grammatical mistake, you understood the question, carry on. Alright, so what you have to calculate, find the net force on what? On 1 coulomb charge placed at the center. Find the net force on the charge 1 coulomb placed at the center. Right? Clear now? Start. If you do this question, then whatever the question might be in this model, we can do. We can go for the next model after this. Right? How? First directions. Right? So you have to stand on 1 coulomb. So I am there on 1 coulomb. So by 12 on 1, force will be there or not? In which direction? So you are here, 12 coulombs is here, both are positive direction. So on you, that direction will be down. By what? By 12 on 1. By 12 on 1. So I am writing it as F12. F12, not F12. Terms your wish. Don't worry about that. Okay. So according to me, I have written F12. F12. Next, 1 positive. So central force, that will be exactly opposite to this 7. Yes or no? So might be little wrong. So exactly 1 should be opposite to 7. So in the direction of the 7, F1 should be there. F1. And next 2 exactly opposite to 8. So F2. Now F3 exactly opposite to 9. Oh, repulsive. I'm seeing 3 and I'm writing not 9. Right? I'm seeing 3. So F3. Likewise, F4, F5, F6, F7, F8, F9, F10, and last F11, F12. So these are all the force that is acting on 1 coulomb. Acting on 1 coulomb, right? So now on 1 coulomb, I will resolve the forces now. Say, so F12 and F6 both are opposite in the direction. So if both are opposite in the direction, we have to subtract. Now try to calculate the magnitude of this one, F12. So what is F12 magnitude? K Q1 Q2 by R square. K Q1 is 12, Q2 is 1. 12 into 1, 12. Divided by radius 1 I gave, so it will be 1. So F12 is 12K. And F6 is 6K. Yes or no? So opposite in the direction, so which one is bigger? So F12 is bigger. So subtract 12K minus 6K will be 6K. So in which direction? In the direction of F12. So I can write it as 6K. Got the point? So I resolved these two. And which one we got? In the direction of F12, I got the final vector with the magnitude 6K. Next, F7 and F1, opposite in the direction of what? Try to write. For F7, what is the magnitude? 7K. For F1, it is 1K. 7K minus 1K will be again 6K. In which direction? In the direction of F7. How much? 6K again. Right? And next F8 and F2, right? So 8K and as well as 2K. 8K minus 2K, 6K in the direction of F8. Next 9K and as well as 3K. Both are opposite in the direction or not? If both are opposite, then I can write it as 6K in the direction of F9. Next 10 and 4. 10 minus 4 it is 6. Alright? Again 6. In the direction of 4. Next again 5 is there, again it is 6. So all the forces are same or not? So that's why I have written that 6K, right? So all the forces are same. So all the forces are same or not? So that's why I have written that 6K, right? So all the forces are same. So I can write this as F. All the magnitudes are same. And now tell me what is the angle between all the forces. Then resolve that. So you can write vector form first. Then calculate the magnitude. I'll write the vector form. If you know the vector form, you can calculate the magnitude easily. So right. So what is the angle between them? Answer yourself. What is the angle? At this angle. What is the angle? Answer yourself. What is the angle? At this angle. What is the angle? So here, what will be the angle between all the forces? So total angle will be 360, right? Now we have to divide into how many parts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's how? Right? So 360 divided by 12, how much? 30 degrees. So each and every angle will be 30 degrees. 30 degrees, right? Everything will be 30 degrees. So here also the same. So this will be 30, this will be 30 degrees. 30 degrees, right? Everything will be 30 degrees. So here also the same. So this will be 30, this will be 30, this will be 30. So this will be 30 and this will be 30. Right? So now resolve the things. That will be your answer. Right? So how to resolve? So this 6K with horizontal, it is making an angle 60 degrees. Right? And this one 30 degrees and this one no need to resolve. And this one no need to resolve. Now here this one with what angle it is making with horizontal again 60 degrees and this is 30 and this one no need to resolve, this one no need to resolve. So resolve the components. Little difficult, try to concentrate. I think if you know vectors it will be easy or else might be little difficult. So now I am considering this F as it is and this F vertical F again as it is. So these two done. Done in the sense I didn't cancel, I have written here. Right? Don't be confused. So now I am considering this 6K and it is making an angle 60 degrees with the horizontal. So resolve. So F 60 degrees. What is the component along the direction of horizontal? So that will be F cos 60. Right? So F sin 60 will be upwards. F sin 60. Clear about the point? Right? Now this is done. Now this 6K making an angle 30 degrees. So one component here, one component upward. So one component here. What is that? F cos 30 and here F sin 30. Right? And next here 6K. This is also done. Now 6K making an angle. This one 30 degrees. Right? So again now F cos 30. So here again F cos 30 is there. One more F cos 30. So I can write it as 2F cos 30 degrees with respect to this. One more sign will be downward. So it will be downward. How much it is? F sin 30. So F cos 30 is there. So I added with this. Same thing. No, magnitude is same and angle also same. We can add. Next 60. This is 60. Now this done. Now this one. So total angle is 60. So F cos 60. F sin 60. So F cos 60 already it is there. So I added the thing there. So now here it is F sin 60. So this will be also done. Now this one directly I have written here. So this is the final thing. Now tell me what are the terms will be cancelled. See F sin 60 cancelled. And F sin 30 also will be cancelled. So resultant only these two. Right? So now what is the resultant along x-axis if I ask? Fx bar. Vector form I am writing. So F is there, F plus and 2F cos 60 plus 2F sin 30, right? So it will be 2F, what is that? Cos 60, 1 by 2, right? Plus 2F cos 30 root 3 by 2 into I cap. Right? Along x-axis, positive x-axis. So I cap, so this 2 and 2 will be cancelled, 2 will be cancelled. So F plus F 2F. So 2F plus root 3 times of F. So if I take F common, so it will be 2 plus root 3 times of I cap. Alright? So this is Fx bar. Now Fy bar if I take, so what is Fy bar? That is nothing but only F is there here, remaining all the terms cancelled. So negative y axis, so it will be F into minus j cap. So finally F bar I can write like this, which is F into 2 plus root 3 times of I cap minus F j cap. So where F value is how much? Where since F which is equals to 6K, so you can write here 6K into this minus 6K into j cap. So resolving a vector into components, if you know that concept, the first model is done. Right? So now the second model. Second model. Again superposition principle in that second model, okay? In that second model. Model 2. So charges I place it like this. Consider charges I place it like this. So for example, consider it as origin. This is origin point, right? So I place a charge of 1 Coulomb here, right? At the origin. At the origin, I place a charge of 1 Coulomb. Now at a distance of 1 meter and at a distance of 2 meters. And a distance of 3 meters and so on up to the distance of 10 meters continuously I placed the charges. What charges I will give, don't worry. So on 1 meter distance I placed 1 Coulomb. So on 2 meters I placed 8 Coulombs, and on 3 I placed 27 Coulombs, and on 10 meters continuously I am placing here, I am not writing. So 10 charges overall I placed along the x-axis with these distances. 1, 2, 3, next 4 is there, next 5, next 6, next 7 and so on up to 10. Right? So at 10 meters I placed 1000 coulombs. Now my question is, find the net force acting on the 1 coulomb placed at the origin. Find the net force on 1 coulomb placed at origin. Placed at origin, right? Find the net force on 1 coulomb placed at what? Placed at the origin, right? So how we can write? So again, superposition principle, right? So now positive repulsive force, yes or no? So repulsive force F1, and again positive, and again positive F2, and so on. All are positive charges, so repulsive forces will be there, and so on F10. So all are in the same direction, so we have to add. All right. So I can write F1 plus F2 and so on up to F10. So which is equals to K. I can take common, right? So now on what? On 1 coulomb. So that one also I can take common, right? So into F1 is what? K Q1 Q2. Q2 in the sense this charge, which is 1 coulomb divided by R square. R is what? 1. 1 square is 1. Plus and F2 on again I took common, right? So now 8 coulombs divided by 2 square plus next 27 divided by 3 cube 3 square plus and so on plus 1000 divided by what is the distance? It is 10, so 10 square. So K Q1 Q2 by R square is that K source charge I took common. So now 1 by 1, 8 by 2 square, 27 by 3 square, and so on. Now 8 I can write as 2 cube, and 27 I can write as 3 cube, and 1000 I can write as 10 cube, right? So 2 square cancelled, 3 square, 1 3 left, and 10 square, 1 10 left. So it will be K into 1 plus 2 plus 3 and so on up to 10. Right? So how to calculate these type of things? 1 plus 2 and so on up to n. If it is there, so formula is n into n plus 1 divided by 2. Yes or no? So we studied in progressions. Those type of progressions here are very important. If GP format is there, so how to calculate this? A divided by 1 minus R. If 1 plus 2 and so on like this, continuous numbers will be there up to infinite or up to n. I can calculate n into n plus 1 divided by 2. So what is n value? Final thing, which is 10. 1 plus 2 and so on up to n, where n is 10. So 10 into 11 by 2, how much? So 10 by 2, which is 5. So 5 into 11, 55. So net force, which is equals to 55 times of K. Where K is 9 into 10 to the power 9, we know. So this is the second model. They will place some charges on the axis, whether it is positive or negative. So we have to calculate the net force. So you have to apply the progressions here. Try to see those formulas. A divided by 1 minus R, I think for GP. So likewise, you have to arrange the things and you have to substitute that formula. You can get the net force. So we'll continue the charges in the next class. Thank you. Bye.